Julian, are you there? All right, let's assume Julian's having audio troubles or something. Travis, you're up.
Okay, what I got is traditionally in Forth, you can't define things like groups and if then else's or if else thens, I should say, or things of that sort outside of a word definition. But in zeptoforth, as of I think version 1.5.0, current version is 1.5.1, of course. Uh, I've implemented functionality where you can go ahead and define almost any kind of control structure outside of a word definition. How it works is that if it sees, let's say, a begin or an if or a case or a do, and it's not compiling, it automatically starts defining an anonymous word in RAM right then and there. Then, once all the control structures that are defined are balanced, it will finish compiling the word, execute it, and then promptly forget it. So as a result, you don't need to define words for throwaway code. Also, I created something called where you've got in traditionally forth, you have begin until, begin while repeat, and begin again loops. What I also defined was an end word that is matched with begin, which is equivalent uh, semantically with a true until, but other than true until, it does not compile any kind of branches or comparisons. So it purely throws away uh, the address on the data stack, but what it does is that it allows you to define arbitrary scopes. And also, if you have a bunch of code that you want to execute at once that you're inputting without being part of a word, it will you can use it to go and say, I'm done defining this, let's execute it. So I've got a few examples of things that I've written that use this just as examples. Share screen. That didn't work. Okay. Like here, for instance, is a bit of code that dumps out an ASCII table. As you can see, it's not in any word definition. And I'm going to use unused to show that the content that it will not go and use up any more space than it did before afterwards. Okay, I'll put it in the ASCII table. and then use unused again. And as you can see from up here, it completely forgot this section of code here after it was done compiling it. And mind you that this code is not interpreted. This is code is compiled. So and furthermore, it always only executed when it's all done. So I'm going to do it, say begin. And then finally, when I do it again, it starts executing. I'm going to stop that. Okay. All right, here's another bit of code that shows the use of my begin end construct. In this case, the display a Pascal's triangle. You know, and there's the Pascal's triangle. And again, no more space is used. And mind you, you can you can use space in the dictionary, like it does here for storing the intermediate states of when it's computing the Pascal's triangle, and it will be uh, released once it's done. One thing, though, you cannot do is expect space that is uh, allotted or compiled within this to persist outside of it. Like, for example, let's say we want to do something that shouldn't work. This, in theory, will work because I haven't overwritten the data in the stack. You know, not in the dictionary, I mean. But let's say I do this. Oh, that's weird. It just perfectly overrode it in such a fashion that it didn't crash. But let's say we go in and do okay. This is this probably isn't a good example because it's not crashing when you'd expect it to. So I'm going to reboot. Reconnect to connect to it. And let's come up, I'm going to come up with a different example. Now I'm going to go in here. Okay, I know what's going on here. It's causing the test to crash. Okay, okay. We're running into a weird sort of uh, undefined behavior where it's actually not crashing when I would expect it to. So forget about that. But in general, the rule is that you can't define things inside of this would uh, that would have their values changed afterwards. So let's say we go in and do, let's say we do that. And then we do, yeah. In this case, we show what's happening is because when I created my true constant for this string here, it overwrote the string partially by itself. Hence why when we try to type the string that we referred to here, we get garbage. So that's a no-no in this kind of setup. I still don't get why it was not crashing when I was trying to go and do what I was doing with tasks, but oh well. Anyways, the this feature in many ways a isn't a huge feature. I implemented it basically in the course of a day, and it doesn't do anything that's really out of the ordinary when you consider most interpreted languages out there. But that's it's something that I feel is missing from a lot of forths because uh, in Python, for instance, you could just do, let's say, if name equals main, and then call your code if your Python module was the main module that was executed. And the and you can execute loops at the top level in Python as well. And that's something I felt was lacking from Forth, and which from talking to someone else, that was one thing that they had to get used to about Forth is that you couldn't do that. But I saw why shouldn't you be able to do it? Because from an implementation standpoint, it isn't that difficult. All you really need is a way to compile to RAM, which in a way does rule out some forths, such as flash forth, which compiles solely to flash. You need to have a way to go in and have a syntax stack so that you can tell when, after all of the blocks that you've defined, that box in the fourth sense, by meaning in the sense of scopes, when you've reached the outermost scope, so you can finish up your word definition, execute it, and forget it. And you need to have some means of resetting the RAM here and latest pointers to their initial state once you're all done. So that's the basics of what I've been doing here. And as you can see, the examples of code aren't exciting, but they do something that I feel has been lacking from most sports for quite some time. So well, on to the next person, unless anyone has any questions or comments.
So it is an interesting capability. I recently was for I forget what I was how I wandered down this particular rabbit hole, but I was looking at an old Apple II forth Graforth, and they that particular one had implemented itself in a way where because because compilation, I guess, was done sort of in a subtly different way, and I'm not actually sure the plumbing mechanism. They had done something similar, and it allowed you to do loops at the interactive terminal. And so on my list of things to figure out was what exactly was the implementation strategy for Graphforth that it had that property. But so definitely an interesting area. I think it is sort of a strange, unexpected thing to newcomers to Forth that you, particularly when you compile a word that is a flow control word, it's sort of counterintuitive that would be something that would not be syntactic. So interesting.
Yeah, I had
And
a quick question um, about the dictionary that you're using there in the Pascal triangle. When you wrote the Pascal triangle, did you include anything that was along the lines of a root square to generate and possibly compress the dictionary to generate better responses? Not sure if I understood it correctly or not. I'm just curious about that.
a root square.
Yes, a root square. If you look at the Pascal, let me go back to it 1 second. I was looking up the formula just to make sure that was correct. 1 second. If you look at the root square, it's n plus 1 CR. Essentially, it's taking the variable n1 and multiplying it by would it be factorials? Would that be correct? And if you multiply it by the factorials, where n can be any positive integer, wouldn't that add to the dictionary and be able to compile it differently? I'm not sure if
Well,
that
I
makes
mean,
sense or not.
to me, I saw how you could do it with factorials, but with factorials, you have to be careful about how you use them because generally a naive approach to a factorial is not what you want because factorials, if you're using, let's say, 32-bit integers, as I
Mhm.
am, a factorial will explode the amount of data you have, even if you got multiple factorials, one on the top of the division and one on the bottom of the division. Basically, you have to make sure that you go and cancel out all but a certain small number of terms to avoid
Mhm.
such explosion. So what I did was had I allotted in the dictionary temporarily 2 rows. And what I would do is I would populate one row and using the other row's contents, and I'd swap the rows pointers so that the new row would then become for the next row the old row and vice versa without having to actually copy any data. So that's what I did.
That makes a lot of sense, actually. Yeah, I never really thought about it like that. Swapping swapping. I just blanked out for a second. Yeah, but that's very interesting. How would you improve on this? How would you build on this? I'm just curious to know a little more about it.
I think Travis may have locked up.
Oh, okay. Uh, everybody else moving. So, or the factorial, not the factorial, the Pascal's triangle is just a example of using do loops without being inside of any given word. It was basically just a test piece of code to throw out there, which used loops and which allotted temporarily in the dictionary while not using any space up after it was completed. So I honestly didn't do a whole lot of digging into the deep math behind Pascal's triangle. So does anyone else have any more questions or comments?
Travis, can you tell us perhaps next month sort of an overview of the forth that you're using? Zepforth? Zeptoforth.
Well, you would like me to do a talk on it?
Yeah, where does it come from? Is it ready for prime time? Do other people use it? Da, 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 da.
I suppose I could. I haven't kept a census of all of my users, but we've got a Facebook group for it and all that. So
That'd be great. Maybe make some slides of the address for the GitHub and the Facebook group and so forth. And we'll also, Brett, could you text, chat list or whatever, send me your email address or send mail to forther at comcast.net so that we can get you on the agenda for next month.